the trigonometric ratios. You already know this bit, don't bother writing it down, just reminding you, these are the three trig ratios. Sine of the angle is opposite over hypotenuse. Cos of the angle is adjacent over hypotenuse. Tan of the angle is opposite over adjacent. Trigonometry relies on similar triangles. We know that similar triangles have angles that are equal, matching angles that are equal. And they have sides in matching ratios. What trigonometry does is it relies on the fact that a right-angled triangle with a particular angle will always have pairs of sides in matching ratios. And these ratios are known and they're programmed into your calculators. So if we're asked to find tan of an angle, all that's asking is type into your calculator, make sure your calculator is in degrees. There's two ways of measuring angles, degrees and radians. We do want to say, hey calculator, we're in degrees. And we just type in tan of 25 degrees. Sorry, it's a bit hard to read there. 0.4663. That's to 4 decimal places there. What that is saying is that if you draw any triangle that's right-angled with a 25-degree angle, if you do opposite over adjacent, you'll get this amount. This lets us find unknown sides and angles. And if you have a look at this triangle here, you'll see I've drawn it with a 25-degree angle. What that says is opposite over adjacent should be about that, because for every 25-degree right-angled triangle, opposite over adjacent should be about that. We can very quickly measure the opposite, about 24.5 millimeters, and the adjacent, about 53. Now, I wouldn't have to do this to answer this question. I've answered that question, but we're just checking. For this triangle with a 25-degree angle, do I get that tan ratio? If I do tan of the angle is opposite over adjacent, in every trig question where you've got a ratio, you should write the ratio. Now, if I do opposite over adjacent, 24.5 over 53, 24.5 divided by 53, I get 0.4623. Not quite exact, but you'll see it's pretty close, and that's because I've got some error in measuring and drawing here. Any triangle with a right angle and 25 degrees, if you did opposite over adjacent, you'd get around about this much. And what that also means is if you do opposite over adjacent for some random right angled triangle and you get about this much, you know your angle's about 25 degrees. Sine of 30 degrees. Now, I've drawn a triangle here with 30 degrees. I could find sine of 30 degrees, that is just opposite over hypotenuse for a 30-degree right-angled triangle. I could find it by drawing a triangle and measuring and checking, or I could find it on the calculator. Obviously, this sort of question wants you to find it on the calculator. Sine of 30 degrees is 1/2. What that says is the opposite over the hypotenuse, 1 over 2, the hypotenuse should always be twice the opposite for a right-angled triangle with 30 degrees. Check. Here's my 30-degree angle. This is opposite. This is hypotenuse. Opposite is 30 millimeters. So you can actually predict what should the hypotenuse be. The hypotenuse should be twice the opposite for a 30-degree right-angled triangle. This should be 60 millimeters. And it is. So trigonometry in right-angled triangles is all about similar triangles. Sine, cos and tan are just the names of, let's use the opposite over hypotenuse ratio. We just had to give it a name. And for any triangle with a particular angle, sine, cos and tan, if it's a right-angled triangle, are always going to be in the same ratio. And as you saw just here, we can use that ratio to work out what an unknown side or angle would be.